So here we have our main course type problems, and nothing fancy. We know what to do. So let's go ahead and get started. The vertical asymptote on all the log graphs, x equals 0. We have on this left side here, we have log base 2 of x minus 3. So the parent function is log base 2 of x. And so we're going to draw the graph log base 2 of x. So we have that. And then let's look at the transformations. First transformation we're going to look at, the a value is negative. So if a is negative, we're going to flip the graph, the parent function, over the x-axis. So we're going to draw the graph. Let's do it in a different color. Let's do it in green. So we're going to reflect. So we know how to do a reflection. And then we're going to notice that we have this 3 right here. So that's the h value. So this means we're going to go to the right 3 units. What is going on here? Right 3 units. And then this 6 out here, that's the k value. That's that kind of number floating. That means we're going to go up 6 units. So all we have to do is take this green graph, and we're going to go to the right 3, and let's do this. Let's make that key point. Let's make that prominent. So that key point, we're going to move that key point to the right 3 units. 1, 2, 3, and we're going to move that up 6 units. 1, 2, 3, 4, 4. Come on now. 4, 5, 6. Boy, it's hard to get that. So that guy right there is our key point, and the coordinates of the key point are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 4, 6. That's our key point. But don't forget, I told you, make sure you move the asymptote first, and the asymptote was at x equals 0, and that has to move over 3 units. So our vertical asymptote that got moved to the right, we don't move asymptotes in log graphs unless we have an h value that's something different than 0. So if we move to the right 3 units, we have a vertical asymptote that's x equals 3, and then we have this graph of the log function that looks just like the green graph. Remember, we moved the green graph. We already reflected about the x-axis. We moved the green graph right 3, up 6, and so we draw the green graph. Whoa. It's supposed to turn green. Okay, it's supposed to be green. So we're going to go log graph just like that. And there again, we have our key point, 4, 6. We could find another key point if we wanted to. We could, again, notice that the base is 2. So we're going to make the argument some power of 2. So we're going to make the argument 5. 5 minus 3 is 2. Log base 2 of 2 is 1. 6 minus 1 is 5. So the graph also goes through the point 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. It should have gone down here a little bit more. So 1. It's really hard to get that. So there's another key point. There's another point on the graph, 5, 5. All right, so let's take a look at the next graph and next function. We have a bunch of stuff going on. We have negative here, so we know we're going to reflect the original graph. So we have log base 3. Let's back up a little bit. So we have log base 3 of x is the parent function. Vertical asymptote was at x equals 0. Horizontal, the key point is at 1, 0. If we reflect the graph, so a is negative 3, so we're going to reflect this graph about the, let's do that in a different color as well. We're going to reflect that about the x-axis, just like that. So that green graph now is what we're transforming. The negative 3, yeah, it'll be a little bit more stretched out, probably go more like that. Okay, but we don't really need to worry too much about that, other than we can find a second point on the graph. So let's go ahead and move the green graph to the left 4 units, and then we're let me do that. And then we're going to go up 2 units. So we take the green graph and we go left 4. Let's do it this guy. 1, 2, 2, 3, 4. and then we're going to go up 2, 1, 2. If we went left 4, which is what we just did, then we have to move our vertical asymptote to the left 4 units. That means that the new vertical asymptote is at x equals -4, and the graph, the key point on the graph is that guy right there, and let me increase the size of that a little bit there, and then we go right here. There, we moved left 4, up 2, the key point is at -3, 2. And again, if you wanted to find another point on the graph, the base is 3, so you just want the argument to be some power of 3. So you could pick x equals -1. -1 plus 4 is 3. Log base 3 of 3 is 1. I mean, you have -3 times 1 is -3. Plus 2 equals -1. So we have the coordinates -1, -1, and that is another point on the graph.